Hello all, welcome back to Data Science Brain. In this video, we will see how we can handle missing data in a data frame. So, let's begin. First of all, let us import Pandas. By this time, you will be already knowing how to do all these things. And then I am actually using the Titanic.csv for actually, showing you how we can handle missing data. And by this time, you will already be knowing how you can actually import this Titanic.csv from your drive. You see how to like mount your Google Drive to the Google Colab. I have actually explained this in a previous video. You can check that out, and you will get your drive here. And from that, you have to find the path where which you have saved this Titanic.csv, and then load it into here. Okay. So you already know this if you have watched my previous videos. Okay. So we have loaded the data. Let's take a quick look at the data. Okay, I haven't loaded it. Sorry. Oops. Okay, I have loaded that, and let's take a look at the data. So we can see the data frame here, and we can see the columns here, every column. So that's how the data frame looks like. So first of all, we should identify the data frame. I mean the missing data, right? So that's the first thing to do. So let us see. df.isNA, we can use the function isNA to find the all the missing values in the data frame. So isNA will return true if it finds a null value. Okay, so it will go through all these columns, and if it finds a null value like we can see here, it will return true. Otherwise, for all these values, it will return false. So data frame will be looking like true, false, true, false, true, false. I will show you an example here. Let us run here and see. See, it's all false if it's not a null value, and if it is a null value, it will return true. So this is not of use for us. So we will find the sum. So sum will go through all the columns, and it will summate the true values, and it will return this. So we can see there are 177 null values in age column, and there are 687 null values in cabin column. So again, this is of no use for us if we don't know how many values are there actually, right? So we use the info function. We have previously learned. So we can see that there are 891 non-null values totally. I mean not non-null. 891 entries are there as written here. Then we have in the age column and cabin column, we can see there are only few non-null values. Okay, so those are the columns with null values, and also embarked has two null values. So that's how we can find out the null values in a data frame. Okay, we can see that there are null values. So after we find that there are null values, we can deal with it. The first method is by dropping them. Okay, so first we can drop the null values. So we can drop all the null values. So let us see how we can do that. So let's create another data frame so that we won't manipulate the original data frame. And we can use drop NA function. So drop NA function will drop all the null values and return the data frame. Okay, so it will drop all the rows with null values. So if a row contains null value, it will drop that row. So this is not efficient, as we can already see, because it will, that means that it will drop 687 rows. Okay, but again, let us see, because we are learning. So let us see how it works. So we will just call the info function to see what we have. I mean, how many entries you have returned. So we can see there are only 183 entries that is returned. So as I have told, it has already dropped all the 687 rows with null values. So drop NA will drop all the rows that contains null values. So we don't like it, right? I mean, it's not good. So what we will do, maybe we don't want to drop the rows, we want to drop the columns with null values. So we will set the access to 1. We will say that I want to drop null values, but only the columns, not the rows. If we drop the rows, then we will lose a lot of data, right? So we will only drop the columns, only drop the culprits who has null values. Okay, so let us do that and see the result. As we can see, we have all the 891 entries, but it has dropped all the columns with null values. See, so that is again not good, right? Because embarked only had two null values, but we have dropped it anyway. So that is also not good. So what we will do, we will use a threshold. We will say that if the column crosses this threshold, then only remove remove it from the data frame. We'll say that. So we'll just copy and paste this. We'll say threshold of 80 percentage. So we'll say that if the data frame has 80 percentage, if the column has more than 80 percentage of null values, then drop it. If it has more than 80% null values, it is of no use to us. Okay, so we'll drop that, and let us see the drop df dot info. So we can see that embarked is there. It hasn't dropped it. Age is also there because it doesn't have 80% of null values, but it has dropped this one. It has dropped cabin, which only had which only had two not for non null values. Okay, so this is good, right? This is useful. This is really useful. If you have a column with lots of null values. Okay, now we will see another way to deal with null values, that is using imputation. So let's use imputation to deal with null values. So the first method in imputation is fill na. Okay, so we can use fill na method to fill the null values. So let us fill all the null values in let's say which column? Let's say cabin column. Okay, so let us create another fill na df is equal to df. Let's say, okay, let us run this first. Oops, sorry, it's not a code. Let's run that first so that we won't mess up. Then let us take the cabin column and replace all the null values in the cabin column by using a value. Let's fill na. So fill na will take in anything inside. So whatever we give inside fill na, it will fill all the null values in cabin column with that value. So let's say, okay, that's not actually fill na. Let's say 0. So we want to fill in all the null values using 0. So let's see how that will work. Okay, let us run this and this. Okay, we have an error. Cabin is not there. What do you mean cabin is not there? Okay, it's capital letter. Okay. All right. So let us print it now and see. Or let us just, okay, yeah. Oh, no, it hasn't done it. What happened? Oh, of course. It created another column. Sorry, I have messed up here. So you should always be worried about, the capital letter, small letter thing. Okay. So we can see, oh, it has again made another cabin. Okay, let's run all this shit again. Okay, we can see that it has replaced all the null values from cabin column by using 0 because that's what we passed in here. So now you might have gotten an idea, right? Maybe you know some mathematics, and maybe if, you can actually fill in some null values using the mean of that column. For example, especially in age column, right? If in age column there's a null value, we don't need sometimes the particular the actual age of that person. We can actually use average here, right? Because age has age doesn't go beyond a specific value, right? We can actually put a limit to age, because the age limit will be anywhere from 0 to 100 or 120, maybe something like that. Okay, so we know that there is a max and min limit for age, so we can actually calculate the average for age and we can put it there. It won't hurt us, right? If the null values is not more than, let's say, 10 percentage, it won't hurt. So we can use the we can use what we can use the mean to fill the null values in age column. So what do we do? So I have told you that we can pass in any values here to fill the null values with, right? So let us fill it with the mean of age column. So we can use the mean function to take the mean of this column, mean of all the age, and we can fill the null values in age column using that mean. So let us see. Let us run it and let us print fill n again. And we can see it has basically taken the, for taking the mean, it has rounded it to this many decimal places. And we can see that, in place where it had a null value, where was it? in the 888th row, there was a null value for h, and it has filled it with the mean of that column. Okay, so that's a useful thing. We can use here median, mode, anything. Okay, you got the idea, right? So that's another thing. Maybe I can show you the let's see, the mode as well. So for that I have to run it again, or maybe I can just use df. Yes. Okay, as we can see, it has used the mode and it has calculated the value for the null values. Okay, so we can put anything in here, fill an and it will fill it with that value that we have provided. Then another thing is we can use forward fill and backward fill. Okay, so f fill and b fill. Okay, so that's the next thing. So what f fill does is that it will fill the null value with the previous value, and what backward fill does is that it will fill the missing value with the next value. Okay, so it will see the next value and it will fill backward. In f fill, it will fill it with the previous value. So it will see the it will go back and it will fill forward. Okay, I hope you get the idea. F fill will fill it with the previous value, b fill will fill it with the next value. So let's see how that works. So it's really simple. We can actually let's cut this. Okay. Oh, okay. Okay. So we can, let's say we can, what was the other column with the null values? Embarked, right? Embarked hard null value. Oh, let's take age again. Let's comment this out. One this to that, and so this in here we will say the method. The method that we want to use is what? F fill. F fill. Okay, we want to forward fill the age column. The null values in the age column. Okay, and we'll print it. We need to do this, and then this, and then this. So as we can see, 880th column had an null value. Okay, it is filling it with again mean. We'll run it all again. Okay, I think I have done something here. We shouldn't copy it like this. Okay. So I'm sorry, I have made a terrible mistake. We shouldn't. We should never copy it like this, because it will always manipulate the original data frame. Okay, so this is a reference. Now we are actually copying. Okay, previously it was a reference. Okay, so let us do this. Let us fill it using the forward fill method, and as we can see, 880th column had the age as null value, and it has filled it using the forward method, forward fill. So what is a forward fill? It will fill it with the previous value. Okay, the previous value was 19, so it filled it with 19. Okay, so similarly we can see backward fill here again. I can again run this and run this and run this, so it will fill it with the uh, oh, it's not working. Even df.copy is not working. What I have done? What have I done? Okay, let's run it all again. Okay. Okay, so it has filled the null value with the next value. Okay, the 26 is the next value, so it has filled it with 26 by using b fill. Okay. Okay, so guys, one more thing again. Sorry. So we need to put in this as well here. Okay, so deep is equal to true. Now it won't change the original data frame. Okay, so sorry for that. Okay, so that's about forward fill and backward fill. So the next way to fill the null values is by using interpolation. So we can use linear or polynomial interpolation for filling the null values. So what is linear interpolation? So it will miss the filling. Okay, it will fill the missing values by using an estimated linear trend, or if it's a polynomial interpolation, it will use it will use, like using a more complex polynomial higher order function. Okay. So in order to understand what I'm saying, you need to learn a little bit about linear regression. So it's basically like this. Let's say, okay, let's say there's a point like, let's say 1 2. Okay. And then there is another point like 2 and 3. Now we need to find a value between 1 2 and 2 3. So 1 2 and 2 3 is in. So I'll draw and show you so you'll better understand. So let's say there is a point here, and let's say another point here. Now we want to find the value of this point. Okay, we want to find the value of this point. So we know these 2 points. So what will we do? So in linear interpolation, what we do is that we will we will draw a line from here to here, and it will find this point where the line almost meets the point where we need to find the value, and it will take the value of this. Okay, so that's why how linear interpolation works. So basically we take two known points. For points we know the values, and we will draw a line, and we will find out the value of the unknown point. Okay, so like that, this will be the value of the unknown point. And in a polynomial interpolation, it will draw a little bit more complex line. So far we have drawn a straight line. I am terribly sorry, because you can consider this as a straight line. Okay, I am really bad at drawing like this. But um, in a polynomial interpolation, it will use a polynomial line. It will use a higher order function. So this is just y equal to mx plus c line. So it will use a, in a polynomial function, it will use a higher order function like x square or something like that. Okay, it will add squares or cubes or something like that. So it will draw like this. You will get a better value. Okay. Okay. So that's about that. So I hope you understood that. Okay. So let's use it. Let's use it in action. So let us just comment this again, and let us delete this. Let us use the fill. Let's again fill the age column. Okay. So we'll fill the age column and interpolate. Interpolate is the function. Interpolate. Interpolate is the function. Okay. And first we will use the linear interpolation. We will use the linear interpolation to fill the missing values using linear regression. Okay. So let us run this and this and this. Oh no, what happened here? Okay, so it has returned a series. Okay, so that basically returns a series. So we have to pass it into the column for which we need to fill. I think I have made a mistake. So let us do this, and let us do this, and let us print it again. So we can see it has filled in the age column null value by using interpolation. It has done a linear regression. It has found out all these non-null points, and it has drawn a line, and in the line, it has find out the by using that, it has find out the approximate value for the null value. Okay, so that's how we use interpolation, linear interpolation. Now we will use polynomial interpolation. Okay, so we will say that we need a polynomial line, not a linear straight line. We need a little bit more complex algorithm. We need polynomial line, and with the order, the x square, we need x square. Okay, so the order will be 2. So let us see how this works. This will be a little bit more better than the straight line. Okay, in most cases. So it has used a little bit more better value. It has found 20.20 as the value. Okay, so that's how we use interpolation to find the approximate the value for in place of null values. Okay, by using interpolation. I don't know why I have put this here. Okay, the next thing is a little bit more advanced thing. It's a model based imputation. Yes, we can see that this is also a model based imputation. If we consider linear and polynomial regression as models, yes, it is model, but this is a little bit more higher order thing. We can use k nearest neighbor imputer for finding the null value. So if you have learned machine learning, you know what is k nearest neighbors. It's basically, to simplify it, like, let's say I don't know height of John, but I know the heights of his family members, 4 of his family members. Okay, so what will I do? So I will guess his height by using the height of his neighbors, like his 4 family members. I think that was a really bad idea. Okay, so basically what it does is that it will find out the null value by using the by using the using its neighbors. Okay, by considering its closest neighbors to guess its null value. So it will say like the neighbors has value like 20, 21, 22, 20 like that. So I'm guessing that its value is around the average of that five neighbors. So like that. Okay, that's how k nearest neighbor algorithm works. Okay, so let us test it using code. So for that, first of all, we need to import. So sklearn is a package that we use for machine learning. Okay, so sklearn.impute import knn. Usually it gives a suggestion. Yeah. Okay. Okay. knn imputer. Okay. So whenever you get a suggestion, just press tab to autocomplete. Okay. So we have run that and let us create an imputer. So we need to create an imputer. So if you don't understand what I'm doing here, don't worry. This is mostly you will learn all these things in machine learning only. Just follow along. Okay. I'm just making an imputer. I'm just telling that I need five neighbors. Okay. So I need to consider five neighbors for finding the null value, or for finding the approximation for the null value. Okay. So that's all I'm doing here. We're creating an imputer, and then let's create another df. Okay, imputer df, and we will use the imputer that we have created here, and it will fit. So fitting is basically we are giving, so we'll use fit transform. Okay, so we are basically giving the imputer the data frame that we need to transform. Okay, so we are giving in whole data frame, and wherever there is a null value, it will transform that and it will send it back to us. I guess that's how this works. Let's see. Oh, there's an error. Okay, so this only works with numbers. Okay, so there's a problem there. This only works with numbers, so we need to do some machine learning things like need to convert the string values into number values and then use it, something like that. Okay, so this doesn't work with string values, so we need to pass in only the columns with number values. Okay, so let's do one thing. Let us create another df to impute df. Let's pass in some columns like age maybe, and let's put in another column, or maybe p class, and create another data frame. Okay, which we can which we can use here, df to impute. Okay, so it has created imputed df, and let's print it and let's see. Okay, so it returns an array, so we need to convert this to a data frame. So for that we have to make it into a data frame. Okay, so we say data pd.data frame, cut this, put this in here, and we'll say columns is equal to df dot not df dot df to impute dot columns. So these are the column names. Okay, so this will let's run it all again. Okay, so these things happen. Okay, these errors happen. It's normal part of coding. If you have seen any videos where there is no error, they are lying. Okay, they are just lying to you. What have I done? Okay, so we have finally done it. So it has used k nearest neighbor algorithm to find out the null value by using its five neighbors. Okay, so that's how a little bit more advanced model imputation works using machine learning models. Okay, so there are other models we can use. Linear regression that we have. I mean, it's basically like the interpolation that you have done above, and we can use another thing. It's a famous imputation method from sklearn. So another thing from sklearn we can import here from sklearn dot impute. Or we can just import it here itself. You know, we can import symbol suggestion. Okay, simple imputer. So simple imputer is again another useful imputation technique for filling in the null values. Okay, so let us say just by using this function. Let's say let's say no. Okay. Let us create another imputer. Okay, let's say symbol imputer is equal to symbol imputer. So the strategy. So we can put in the strategy here. So see, we have strategy here. So here are all the suggestions. Okay, these are all the attribute values or the parameters that we can set. Okay, so strategy is equal to, let's say, mean. Mean is our strategy. Okay, we need mean, or let's say most frequent value. Okay, frequent value. So mean, I mean, we cannot use mean on like categorical data, right? So that's why we have passed in the second function, like most frequent. If there is no mean, then use the most frequent. Okay. So for categorical data, it will use most frequent, and for numbers, it will use mean. So that's a useful thing, isn't it? Okay. So imputer df is equal to symbol imputer dot fit transform. We will again use fit transform. So fit transform, all these methods, it's common thing in SQL and functions. Okay, so it will fit the data and it will transform the data. Okay, so that's all it does. It will fit and then it will transform. So let us say, let's again run this and run that and again run that. Oh no. Okay. No, there is no most frequent. Must be a string among. That's wrong. Okay, we cannot pass in this many things here, I think. Let's say. So that was the problem. Okay. So no, I was wrong. We cannot pass in both of them here. We can only use one at a time. Okay. So it is again returned as an array. Again, we need to use pt dot data frame and I need to do symbol imputer and columns is equal to df dot impute same column names from df dot. We have learned this before. Okay, we can use columns to get the column values. Okay, so we can only use one thing at a time. Okay, so use it wisely. If it's a categorical column that we need to impute, use most frequent. Otherwise, use mean, median, mode, anything. Okay. So again, run all of that, and let's see the input df. Okay, so it has used simple imputer mean strategy to impute this data set. Okay, so that's how that works. So that's all about how to deal with missing values in a data frame. We have seen many ways. We have first seen how to identify missing data, how to use drop in a how to drop the rows and how to drop the columns. And we have seen that dropping the rows is bad idea, so we should use columns instead by passing in access equal to 1. Then we have seen that that is also a bad idea if we are dropping all the columns. Then we have said that if the column only contains more than 80% of null values, we need to drop it. We learn how to use threshold for that. So we have found that that is a really useful function. Then we have said that we don't need to drop, we need to fill in. So we have seen how to use fill in using any random values. Then we have seen how to use mod, median, or any other values like that. Then we have seen fill and using b fill and f fill, like forward fill and backward fill. And we have seen how to use interpolation, like polynomial and linear interpolation. It basically does linear regression or polynomial regression to find the values. And then we have seen a little bit more advanced thing, like using k nearest neighbor algorithm to find the null values by using its values of its 5 neighbors. And that's it. And then what? Then we have also seen simple imputer function from sklearn to impute the values. Okay, so we have seen all these values. You will be using only some of these values in your daily usage. Okay, so I hope you found this video helpful. If you have found this video helpful, you know that this I'm just starting out in this channel, and kindly like this and subscribe, and share this with your friends. Okay, and post your like opinions in the comment section. I can improve on whatever you have posted there. Okay, and if you need any explanation on any topics further, kindly post that as well. Okay, so thank you and see you in the next video.